Okay, in this video, we're going to be talking about section 4B, which is the power of compounding. We'll first look at simple versus compound interest, and we'll look at some definitions here as well. The definition here for a principal is the balance upon which interest is paid, okay? That's used in most financial formulas here. So it's going to be the balance on which the interest will be paid. It's going to be the amount that you invest or the amount that you borrow. Okay? And then simple interest is going to be interest paid only on the original principal and not on any interest added at later dates. Okay? So that simple interest is just going to be on the original principal. Okay? Compound interest is going to be interest paid on both the original principal and on all interest that has been added to the original investment. So that's the difference between simple interest and compound interest. Okay? Now these first two examples deal with simple interest. So in this case here, if we want to find the interest, we're going to use this. I is equal to P, which is the principal, multiplied by your APR. That's going to be the annual percentage rate times Y. That's going to be the number of years. Okay. Okay. Now the APR is the annual percentage rate as a decimal here. So when you convert a percent to a decimal, you always drop the percent sign and divide by 100. Okay. The Y is going to be the years, which is the time. And to find the amount, we'll always take the principal and add that to the interest, which is your I. That'll give you the amount that you'll have at the end of a certain time period. So like in example 1, you want to calculate the amount of money that you will have at the end of the indicated time period. So here you're gonna invest $2,000 in an account that pays simple interest of 6% for 30 years. So in this case here, excuse me, your principal is $2,000. The APR, which is the annual percentage rate, that is 6%. Now, we need to convert 6% to a decimal. Now, on the calculator, you can do this. You can take 0.06, divide that, take 6. 6 divided by 100. And that will give you the decimal of 0.06. Y is the number of years. In this case, it will be 30 years. Okay, so in this case, here we're going to use this formula here to find out what the interest is first. So it's I is equal to P times your annual percentage rate times Y. P is your principal, by the way. So here, the principal was $2,000. That's going to be multiplied by the APR of 0.06 times Y, which is 30. So if I take 2,000, multiply that by 0.06, and then multiply that by 30, you're going to get $3,600. So the interest at the end of 30 years will be $3,600. And now, to find the amount of money that you will have at the end of 30 years, we need to take the principal balance, the principal, or the amount that we invest, add that to your interest. That's going to be the total amount. A is equal to P plus I. Your P is 3,600, and your I, no, 2,000 is your principal. Your I is 3,600. So add 2,000 to the 3,600, you're going to get $5,600. So the amount of money you will have at the end of 30 years will be $5,600. Okay. Okay, now the next example pretty much is done the same way. You deposit $3,500 in an account with an annual interest of 4.8% for 5 years. And we want to find the amount of money that you will have at the end of 5 years. So in this case here, we need to identify what P is. That's your principal, which is $3,500. R is the interest rate. Well, actually, I just say APR just to be consistent. Your APR, that's 4.8%. Now, to convert 4.8% to a decimal, again, we do 4.8 and we divide by 100 to get the decimal amount of 0.048. And your Y, that's going to be 5 years. Okay, so now to find the interest first, we use that same formula that we used in the first example. I is equal to P times APR times Y. Your P in this case is 3,500 times your APR of 0.048 times Y, which is 5. So in this case here, we multiply 3,500 times 0.048 times 5, you'll get $840. That will be the interest on this deposit that you will earn at the end of 5 years. Now the amount at the end of 5 years, in this case, to find that out, we have to do the amount equaling to the principal plus your interest. Here your principal was $3,500. We're going to add that to the interest of $840. Add those two together, your sum will be $4,340. That will be the amount you will have at the end of 5 years. Okay. Okay, so that's how we use our simple interest formula. Okay. Now on the next page, we have our compound interest formula. And this is for interest paid once a year. And in this case here, this is the formula that we'll use here for interest paid once a year. The compound interest, or the amount, will be equal to principal multiplied by the quantity of 1 plus APR, and that will be to the power of Y. Here your A is the accumulated balance after Y years. P is the starting principal. Your APR is the annual percentage rate as a decimal, and Y is the number of years. Okay. So in this example, we're going to look at the difference between simple interest and compound interest. We're going to complete the table for the following investments, which shows performance, that's interest and balance, over a 5-year period. Suzanne deposits $3,000 in an account that earns simple interest at an annual rate of 4.2%. Derek deposits $3,000 in an account that earns compound interest at an annual rate of 4.2% and is compounded annually. Okay, so now let's look at Suzanne's account. After the first year, okay, she deposits $3,000. And the annual rate of 4.2%, APR of 4.2%, but 4.2% as a decimal will be 0.042. Take the 4.2 and divide that by 100, you'll change that percent to a decimal. And this is going to be over 5 years, by the way. So for the first year, we have to use this formula. A is equal to, well, actually, we're going to find the interest first, which is going to be P times your APR times Y. For year 1, that means Y is going to be equal to 1. So here the interest here will be 3,000 multiplied by 0.042 times Y, which is 1. And this is only after the first year. So 3,000 times 0.042 times 1. Here I get $126. So for the first year, her annual interest will be $126. Now, for year 2, year 3, year 4, and year 5, Suzanne's annual interest will remain the same because, by definition of simple interest, that's going to be paid only on the original principal and not on any interest added at a later time. So, for year 2, it's 126, year 3, year 4, year 5 is still $126. Now we're going to find out what Suzanne's balance is. Okay? After the first year, she starts off with $3,000, and after the first year, we're going to have $126 as an annual interest, which will give her balance after the first year, $3,126. And then for the second year, we'll add 126 to the 3126. That'd be $3,252. The next year, year 3, we add another 126. That'll be $3,378 after the third year ends. And then at the end of the fourth year, we'll add another 126 to the 3378. You'll get 3,504. And then finally, after the fifth year, we'll add another 126. That'll be $3,630. Okay? So after the fifth year, Suzanne has $3,630 in her account. Okay. Now we're going to look at Derek's annual interest. Now, Derek's annual interest is going to be 4.2%, and it's going to be compounded annually. Okay. That's going to be the difference here. because Suzanne's deposits are, her account earns a simple interest. Derek's is earning a compound interest. So let's look at Derek's account after year one. So now we got to use this formula. A is equal to P times the quantity 1 plus APR raised to the power of Y. And his principal is $3,000 as well, multiplied by 1 plus, his APR is also 4.2%, but as a decimal, it's going to be 0.042 raised to the power of Y, and in this case, Y is going to be equal to 1. So let's enter this in the calculator. We got 3,000 times, left parentheses, 1 plus 0.042, close parentheses. Now for your exponent, you use this button, which is a hat key, and then to the 1, and then hit enter. That will give you the amount of $3,126. So after the first year, Derek has $3,126. Now I'm putting that under Derek's balance because I need to know what the annual interest is going to be. Well, to do that, we do the interest that's going to be equal to the amount that he has minus the principal. He started off with $3,000. Well, he has $3,126, but he started off with $3,000. So we subtract $3,000 from $3,126, you'll get $126. And that will be the amount of interest that he has after the first year. Okay. Okay, now after the second year, okay, we're still going to use this formula up here, and we're going to use the same values here, but the only thing will change is your exponent here. So here I'm going to have A is equal to 3,000 times 1 plus 0.042, but this time that quantity will be to the second power because it's year 2. So if I do here's what I can do here. Since I've already got this, to save myself from typing all that in, I'm going to do second and then press enter way down here at the bottom. Second enter will pull this up. And then I'm going to use my left arrow key to go up here and change that 1 to a 2. And then hit enter. And I'm going to round this off to the nearest dollar. So this amount will be $3,257 even. So it'll be $32.57. And now to find the interest, I'm going to put that $32.57 here. Now I'm going to take this amount and subtract from it the balance that he had at the end of the first year. That will give me the interest for that only for year 2. So if I do $32.57 minus the previous year 1 balance of $31.26, I'm going to end up with $131. So for that second year, he's earned an additional $131. Now for the third year. For the third year, we're going to still use that same expression, but here it's going to be to the third power because it's a third year. Okay. And I'm going to do this second and enter to pull this up. Use my left arrow key to go up to the exponent and change that 2 to a 3. And then press enter. To the nearest dollar, it will be $3,394. And then to find the interest, that $33.94 will be the balance at the end of the third year, by the way. To find the interest, I'll take $33.94 minus the balance before that, which is $32.57. So if we subtract that, you'll get $138. I'm sorry, $33.94 minus $32.57. It's actually $137. So Derek has picked up an additional $137 after the third year. And now for the fourth year, year number 4. That'd be 3,000 times 1 plus 0.042, and that's raised to the 4th power. And in this case, second enter. Oops. I'll go ahead and enter it in again. 3,000 times, and then left parentheses, 1 plus 0.042, close parentheses, the hat key for your exponent, and then 4. So this will be $3,536. Actually, $3,537 if I round to the nearest dollar. And then, to find out what that interest is, that $35.37 after the end of the 4th year, I'll subtract that from this amount, $33.94. This will end up being $143. That's going to be the interest that he's picked up during the 4th year, at the end of the 4th year. Okay. And then finally for year 5. It'll still be this, but it'll be to the 5th power this time. Now this one I can do second enter because I've already did this. Use my left arrow to go to the exponent and change it to a 5. And then to the nearest dollar would be $36.85. So it'll be $3,685. And to find out what that interest is, take the $36.85, subtract the amount that was at the end of the 4th year, $35.37. So this will end up being $148. Okay. Now you can see the difference between Suzanne's balance at the end of 5 years when it's compounded, well, with a simple interest, and then what Derek's amount would be by compound interest, compounded annually. Okay. Now, let's look at some examples just using that compound interest formula. Here we're going to use the compound interest formula to determine the accumulated balance after the stated period. Here we got $1,000 invested at an APR of 9% for 4 years. Okay, and we want to find out the amount of money after 4 years if interest is compounded annually. Okay, so now we've got a principal, that's your P, of $1,000. Your APR, that's the annual percentage rate of 9%. Now, 9% is a decimal. If you do 9 divided by 100, you'll get a decimal of 0.09. And then your Y, which is your number of years, that's going to be 4. So now we can use our formula of A is equal to P times the quantity 1 plus APR raised to the Y power. So here your P is going to be $1,000 times 1 plus your APR of 0.09 raised to the Y, which is your 4. Now this we can type into the calculator. So here you got 1,000 times, and then left parentheses, 1 plus 0.09, close parentheses, and then the hat key for your exponent, 4. And in this case, this will give you $1,411.58, rounded to 2 decimal places.